All right, hello everybody. I'm doing this video for all my students that were absent this Friday and the students that were in class that want a recap over today's lesson. We went through two different worksheets. One of the worksheets was called Double the Fun. The other one was, I think, Half the Work. With these two worksheets, we are using our double angle identities and our half angle identities. You will need your green sheet that has all your identities on it and your yellow trig table that we had from our other earlier units. If you have a graphing calculator, that'll help with some of these. If not, you can check your answers when you come to class on Monday. Okay, so let's first start with the double angle identities. This is problem number 1 on the worksheet that says, I think it says double the fun. I have no idea. I can't remember what I named it. Anyway, so with this worksheet, the first part, they want you to use your sum and difference identities from yesterday's work to get your double angle identities. And so basically what we're doing is if you have 2x, that just means that you have x plus x. So here we are replacing our a and our b with x's. So with the sum identity for sine, it's going to be sine x times cosine x plus cosine x times sine x. Okay, so that's what the formula looks like. Now we need to step back from this a little bit and take a flashback to like 6th grade where we were talking about, or you were learning about, the associative and commutative properties of addition and multiplication. So basically if you have 2 times 3 you get 6, and if you have 3 times 2 you also get 6. Okay, so here the order that these numbers in doesn't matter. You can have them in any order and you'll both get 6. Well, if you have these two and you add them together, you get 6 plus 6 and you get 12. Well, if you have both this and you add them together, basically you have 2 times 2 times 3. Well, if you do that multiplication, 2 times 2 is 4, 4 times 3 is 12. So whether you add them together like this or you multiply all your numbers together like that, you still get 12. The associative and commutative properties of addition and multiplication apply to your trig functions. So this sine times cosine is the same thing as cosine times sine, you just switch the order. So you can reduce this as just writing it as 2 times sine x times cosine x. Because you have 2 of these terms, you just multiply it by 2. Okay? So this is your double angle identity for the sine function. And if you look in your green notes, you'll see it right there. All right, now for cosine, you have same kind of situation for the double angle identity. You split the 2x, write it as x plus x, and then you plug in x's for your a's and your b's in your cosine function. And you have cosine x times cosine x minus sine x times sine x. This is the sum identity for cosine. Notice you have a minus here, and this time your cosines are together and your sines are together. So anytime you have like cosine times cosine, that just reduces to cosine squared x, and here the sine times sine is reduced to sine squared x. So this is your first double angle identity for cosine. But if you look in your notes, there's 2 other identities. Problem number 3 has you using this answer right here that you got right here and using it to get the other 2 answers. So let's look at this page. So I started with my answer for number 2, the cosine squared x minus sine squared x. And this time I want to change it so that I only have cosine in the equation. So I need to get rid of this sine squared x. Well, if you look on your identity chart, because this is squared, look at your Pythagorean identities, and you'll find that you can replace sine squared x with 1 minus cosine squared x. And then you distribute this negative sign, and you end up with cosine squared x minus 1 plus cosine squared x. Then combine like terms. You have 2 cosine squared x's, so you have 2 times cosine squared x minus 1. This is the next double angle identity for cosine. And then the third one, same type of thing. Start with the cosine squared x minus sine squared x. And this time we want to keep sine squared x, but we want to get rid of cosine squared x. I'm going to let you look at your green chart, see what you can replace cosine squared x with, combine like terms, and see how you get to 1 minus 2 times sine squared x. Okay? And then for number 4, same kind of thing, but now we're working with tangent. Your sum identity for tangent is this equation, and we are replacing the a and b again with x's, so we end up with tangent x plus tangent x in the numerator, and then 1 minus tangent x times tangent x in the denominator. Well, the numerator, you can just combine those as 2 times tangent x, and the denominator, you have 1 minus tangent squared x, okay? This is the final answer. If you look in your green notes, that's the formula for your double angle identity for tangent. You can't simplify it any further. Yes, if we wanted to, we can replace the tangent x's with some other function. We can replace it with sine over cosine, or we can look at our Pythagorean identities and replace this with tangent squared, or not tangent, we can replace it with secant squared x, I think. But we just want the trig function of tangent in this equation. As long as we don't have sine, cosine, secant, cosecant, any of the other trig functions, we're good. So just leave it like this. This is your double angle identity for tangent. Okay, now for the back, they use those double angle identities, and basically we're proving that they work by plugging in different values for x. I'm not going to do all of the problems with you, but we will do some of them. Let's look at number 6. On the left side of the equation, we want to plug in pi over 6 in for x. And so we're going to have cosine 2 times pi over 6. Well, 2 times pi divided by 6 reduces to pi over 3. Look on your trig table, cosine of pi over 3 is going to just give you 1/2. Okay? Now let's look at the right side of the equation. We have 2 times cosine squared x minus 1. So we're replacing our x with pi over 6. Okay? And we look on the trig table, cosine pi over 6 is the square root of 3 over 2. Because your cosine function is squared, you also need to square your ratio. Okay, so we're going to have 2 times the square root of 3 divided by 2 squared minus 1. Well, square root of 3 squared is 3, and 2 squared is 4. So now we have 2 times 3 is 6 divided by 4. That fraction, 6 over 4, will reduce to 3 over 2 minus, now remember with fractions you have to have common denominator, so we're going to change this 1 to have a denominator 2. And so the numerator will also be 2. Excuse me. So we'll have the fractions 3 over 2 minus 2 over 2. That reduces to 1/2. And if you compare your answers, you notice that both answers are the same. Okay, so let's look at number 7 real quick. Same kind of thing. We plugged in pi over 3 for x here. We have tangent 2 pi over 3. Look in your trig table, you get negative square root of 3. Come over here, plug in pi over 3 for your x's. You have 2 times tangent pi over 3 minus tangent squared pi over 3. Look on your trig table. Tangent of pi over 3 is the square root of 3. Replace your tangent pi over 3 with square root of 3. Again, down here, you're squared. Your numerator just becomes 2 times the square root of 3. In the denominator, the square root of 3 squared becomes a 3. 1 minus 3 is negative 2. Your 2's cancel out here, and your final answer is negative square root of 3. Okay, again, compare your answers. You have the same answers. Last one that I'm going to work with you on this worksheet is this one. You'll have a problem very similar to this on the test. You have, I know this page is really cluttered. Take your time. With the information you're given is that cosine theta is 3 over 4 and sine theta is 4 over 5. If you notice by the diagram, theta is in the first quadrant, so everything's positive. But when you double that angle, you're going to be in the second quadrant, and all your x, anything with an x value in it, is going to be negative. Okay. Now with this, they do not give us our tangent theta, but we know that tangent theta's ratio is your y over your x, or sine theta over cosine theta. We can plug in our y and our x's, we multiply by the reciprocal, and we find out that tangent theta equals 4 over 3. Now we know what sine, cosine, and tangent equal. We can plug everything into our double angle identity for sine. Look in your trig identity sheet. We know that the formula is 2 times sine theta times cosine theta. So sine theta is 4 over 5, cosine theta is 3 over 5. We get 2 times 4 is 8, times 3 is 24, and then 5 times 5 is 25. So sine 2 theta, the ratio for that is 24 over 25. Now cosine 2 theta, we decided to use 2 times cosine squared theta minus 1, and so cosine's 3 over 5. We need to square that. We get 9 over 25, multiply that fraction by 2, you get 18 over 25. Now your 1, you need a common denominator, so 1 is going to become 25 over 25. 18 minus 25 gives you negative 7 over 25. That's the cosine 2 theta, that's what the ratio is. And then for tangent 2 theta, we have 2 times tangent theta, which is 4 over 3, minus 1, or sorry, divided by 1 minus tangent squared theta. So we plug in tangent theta and then square it. We get 8 over 3 in the numerator, and then 1 minus 16 over 9 in the denominator. The 1 becomes 9 over 9, so we can subtract. In the denominator, we end up with negative 7 over 9. The numerator is just 8 over 3. We have a fraction over a fraction, so we need to multiply by the reciprocal. Your 3 is going to cancel out. The 9 gets reduced to 3, so we have 8 times 3 gives us negative, or sorry, don't forget the negative sign here. So 8 times negative 3 gives us negative 24 divided by 7. And this is your double angle identity for tangent. Okay? Or excuse me, that's the double angle ratio for tangent. So anything else on this worksheet that we didn't go through, you need to work out on your own. Use your trig tables if there's, and give me exact answers for most of this. If there's any of the problems where you need to find the decimal or the rounded answer, you can go ahead and wait until you come into class on Monday and give me, and you can do the, or type the formulas in your calculator. All right, let's move on to the half the work worksheet. With this one, you are using your half angle identities that are on the green sheet. And in most of my classes, we all wanted to do problem number 2 and 3. I told them they could only choose 2 of those problems. And so for problem number 2, you're plugging in 240 in for A, and then you're plugging it in both on the left and the right, figuring out what your answer is, and then comparing the answers. So for cosine 240 divided by 2, it's going to give you cosine 120 degrees. If you look on your trig table, go down the degree column to 120, check what cosine is, and you get negative 1/2. And then over here, you can plug it in. We know that, well, first let's look at our angle, whether it's going to be negative or positive. We know that the angle 240 degrees is in the third quadrant, but the half angle is in the second quadrant. And in the second quadrant, you are negative. Your cosine function is negative, so our answer is going to be negative. Whether the answer is negative or positive depends on what quadrant we're in. And because our angle is 120 here, we're in quadrant 2. Quadrant 2, your cosine function is negative, so we're going to keep the negative out here. Now, for the rest of the equation, look on your trig table for your, or not your trig table, but your trig identity sheet, the green sheet, for your formula for your half angle for cosine, and you have the square root of 1 plus cosine of 240 divided by 2. If you go down your trig table, 240 degrees, your cosine function is negative 1/2. So under the square root, you have 1 minus 1/2 divided by 2. 1 minus 1/2 becomes 1/2, and then divided by 2 over 1. I know this doesn't have a 1 in the denominator, or at least it's not showing 1 in the denominator, but it is actually there. So you multiply by the reciprocal. 1 times 1 gives you 1, and 2 times 2 gives you 4. We still have the negative outside that square root symbol. Well, the square root of 1 is 1, and the square root of 4 is 2, and then put the negative there. And compare your answers. They are the same. All right. Let's look at number 3. Tangent x divided by 2 equals 1 minus cosine x divided by sine x. You'll notice that with your half-angle identities, you have 2 different versions of your tangent half-angle identity. You can use either one. This time we're using this one. We are checking to see if we can plug in pi over 3 into both sides and get the same answers. So for on the left, we have pi over 3 divided by 2. You multiply by the reciprocal here, you get pi times 1 is pi, and then 3 times 2 is 6. So we're looking for tangent pi over 6. You look in your trig table, and you'll get the square root of 3 over 3. And then on the right side, plug it in 1 minus cosine pi over 3 divided by sine pi over 3. On the trig table, we know that cosine pi over 3 is 1/2. And sine pi over 3 equals square root of 3 over 2. And then 1 minus 1/2 is just 1/2 divided by square root of 3 over 2. You've got to multiply by the reciprocal. The 2's cancel out. You get 1 over square root of 3. And then you can't leave your square roots in the denominator, so you're going to do square root of 3 over square root of 3, multiply those together. 1 times square root of 3 is the square root of 3, and square root of 3 times the square root of 3 is 3. Compare your answers. They are the same. Okay. On the back, we are only going to work through problems 5. You get to do the rest on your own. And yes, I know most of you do not have calculators at your house. If you want, look for one online that you can plug in trig functions for, or you can just get your exact answers, so just work on the right side of the equation, and then when you come into school, you can find the answers on the left side. So for number 5, we plugged in sine pi over 12 in the calculator. We made sure that our calculator was in radian mode first, and we got the answer 0.26 here. And then we plugged everything in to our half-angle identity for sine to figure out what the right side would equal. And a couple things I need to point out is the half angle is pi over 12. Okay, so when you set it up, you have pi over 6 over 2 gives you pi over 12. Well, that your numerator, this pi over 6, that is what your x is. So when you plug in, hold on, sorry. When you're using the half-angle identities for the right side, you're going to use pi over 6 in the formula instead of pi over 12. Okay, so we just used our half-angle identity. We have 1 minus cosine pi over 6 divided by 2. This formula gets really crazy. So cosine pi over 6 is just the square root of 3 over 2, but in order for us to subtract fractions, we have to change the 1 to 2 over 2, and so we get 2 minus the square root of 3 over 2, and then in the denominator we have just a 2 there, and it's 2 over 1. We multiply by the reciprocal, and we get 2 minus the square root of 3, where are we? 2 minus the square root, the square root of 2 minus the square root of 3, and then 2 times 2 is 4. Well, we can't leave the square root of 4 in the denominator, so we're just leaving the numerator alone. You cannot reduce this at all. The final answer, it really is the square root of 2 minus the square root of 3 divided by 2. Okay. Square root of 4 is just going to be 2. Now we don't have a radical in the denominator. We're good. Cool thing is if we were able to plug this whole thing in the calculator, it would give us 0.026. Okay? You just need to be very careful with how you plug this into the calculator. It's very easy to type it in wrong, especially with the square root here and the square root here. Okay. So really quickly, if you look at your half-angle identity for cosine, you'll notice the only difference between the sine and cosine is this plus sign right here. So you could reset this formula up and do all the steps again, but really the only difference is in the final answer, this minus here is going to be a plus. So if you want to do all the work, you can, or you can just write the answer and change the minus sign to a plus. You're going to notice that is going to be the case with all of your half-angle identities when you are finding sine and cosine. You'll just change the minus to a plus. Okay, now with tangent, it's a little bit different. You have 1 minus cosine pi over 6 divided by sine pi over 6. Again, you substitute in square root of 3 over 2 for the cosine pi over 6, and you have to multiply by your reciprocal. You end up getting rid of the 2's here in the denominator, and so your final answer for tangent is 2 minus the square root of 3. Right here, the tangent pi over 12 is, if you plug that into your calculator, you'd get 0.27. And if you type this all into the calculator and plug and push enter, you'll still get 0.27. You'll get the same answers. So these two answers match, and these two answers match. And remember, with your half-angle identities, sine and cosine can be negative or positive. You just have to figure out what quadrant you're in. Well, pi over 12 is in quadrant 1, so both of these will be positive. Okay. There's other problems on this worksheet that we have not gotten to that is homework. Please do as much as you possibly can, and come Monday we will be working on some other stuff. You can turn these in on Monday if you're done. If you want to come in for tutoring, I have tutoring next week. Will be on Monday and Wednesday afternoon. All right. I hope you were able to understand most of this. I know I went by fairly fast and I was talking real fast, so you might have to pause it, rewind it, and watch it again. All right. See you guys Monday.